I indicated that we're going to look at grade 10. That is why when I greeted you, I said, good morning, grade 10. The focus today is on grade 10 topic. We have, I think, about 8-9 topics in grade 10. But the special attention now will be given to the functions. It means we're going to focus on functions today, which is a very, very important topic, grade 10s. So if you understand it now in grade 10s, then you're going to need it in grade 11 as well as in grade 12. So please make sure that we pay attention and make sure that you understand the topics. Yes, now we are laying a foundation for the next grade, which is grade 11 as well as grade 12. Right. Let me start. Right. Like I indicated, we're going to look at the functions. Right, under the functions, I think we have about 4 functions that we're going to talk about. We have a straight line graph, we've got a parabola, or you can call it a quadratic functions. We've got parabolic functions as well as the exponential. Those are the 4 algebraic functions that we have. Yes, I must be specific because we still have trig functions as well. But now the attention now will be given to these functions here. Right, let's look at the concept in functions, very important, right? Maybe I must give a clear indication here first. We've got the formula. Sometimes you may give in the formula, or you may give in a table, or you may use 1 or 2 of them, right? Now, for an example, you are given the formula y is equals to 2x. This is the equation that is given. From the equation, then we can draw or construct the table. Now, if we are to draw the table based on the given information, we are going to have the x values -2, -1, 0, 1, 2, 3, and we can get the y values. Maybe one can guess, how did I get that -4? -4, I took the x, then I substituted there. 2 times -2, then it's a -4. Then the same going to apply. 2 times -1, then it's -2. You can do that up until you get what? You get 2, 3. You substitute the value of x here, then you get the corresponding y value. But let's understand it now. What we are seeing on the table says x in this relation is called the independent variable. X in this relation is called the independent variable since the values of x were chosen. Remember now we selected -2, -1. One can go to -4, -3, -2. Now we decided just to select the few that are closer to 0. Then here we are. However, it is clear that the values of y based on the graph, it is clear that the values of y depend entirely on the values of x. You see now for us to get these values of y, we substituted in the values of x to get -4. We substituted in -1 to get -2, all the way up until you get 3. When you substitute in 3, you get what? You get 6. So you can now see now as well as the rule used. Now we used the 2. Now y is equals to 2x. Now in this relation, then we can now call the y the dependent. Remember, x is independent, and then the y, then we call it the dependent variable. Very important to note the 2, because if we can miss it here, we're going to struggle going forward. Now, let's now zoom into the graphs now. Right, in order to draw graphs, we need to plot coordinates or ordered pair on the Cartesian plane. Very, very important. We've got a coordinate or ordered pair. Those are the 2. Now, what is it that we need here? What is it that we need in that coordinate? We need the independent variable. We need independent variable as well as dependent variable. You remember on the table earlier on, I said the independent variable represented the x. Those are the x values. Then the dependent variables are the y. For us to sketch it or to plot the graph, we need to have that coordinates. On the coordinates or ordered pairs, we have independent variable as well as the dependent variable. Okay, now on the Cartesian plane, this is what we have now. If I were to sketch the graph, or if I were to plot the point, I would have the x -2, I will have the y -4. I will have the x -1, -2. These are now the points that are plotted on the Cartesian plane. Very, very important. Now, if I'm asked to plot the following 1 and 5, x is 1, Here we are. Wherever we see x, 1, then 1 goes with what? Y, 5. Then the point is supposed to be here. Can you see that? You do that point here. Then the same will apply. If you look for 3, x is 3, y is y. Very important. You start first with x, and then after that, the x must go with what? The x must go with a y. Okay. Right. The next one that you look into is the fx functional notation. Right. Remember, it can be f at x, it can be g at x, it can be h at x. This is equivalent to y. It's equivalent of y. Very, very important. Now, look at this example here. Given that f at x is equals to 3x squared minus 3. Now, I can also say y is equals to 3x squared minus 3. Then they asked me to determine the value of f at 2. I need to understand what is happening. F at 2. Therefore, what is the meaning of this one? It means on the function f at x, we are going to substitute x by what? By the 2. It means this 2 here, it represents the x. So how do I do that? Then I have f at x is equals to, then 3x squared minus 3, which is the function given. Therefore, in place of x, I replace it by 2. So I'll have 3, 2 squared minus 3. So 2 here is a 4. Then 4 times 3 is a 12. Then 12 minus 3 then will give us what? Will give us that. Very, very important. Please make sure that you know how to work it out. Very, very important. Right now, what about the second one? B. It says f at x is equals to 0. B says f at x is equals to 0. In this case, I said f at 2. This one represented the x. But in this case, remember what we said earlier on. F at x is equivalent of what? Of y. So it means f at x is equals to 0. It says to us that y or f at x equals to 0. In the functions, wherever I see f at x or h at x, then I'm going to replace it by 0 like it happened in this example. So we have a 0 is equals to 3x squared minus that. So it means in this case, then what is it that I will be determining? I will be determining the value of what? The values of x. That is why you see here, you have x squared is equals to 1. Then when you apply the square root on both sides, you get x is equals to plus or minus what? Plus or minus 1. Please, very, very important. Remember when you do what? When you apply the square root on both sides, don't forget that you need to indicate that plus or minus. Yes, I just want us to verify. I want us to verify that 3. We've got 3 into 2 all squared. Then it's a minus 3. Yes, it's supposed to be 9. I just felt that this one is supposed to be 9 and not 8. Please, just take note of that. F at 2 here is equals to 9, not 8. Okay, thank you very much. Right, the next part that we're going to look into. Number 2, we are given that if f at x is equals to 2x squared minus x plus 1, determine the value of. If we are given that f at x is equals to 2x squared minus x plus 1, determine the value of. What must happen? Based on the example that we did earlier on, we know that f at 1, we've got number 1, we've got 1 is f at 1. So we need to look into that. Let's see what's going to happen with that. F at 1, then equals to, then let me copy the equation very quick. Then the equation is f at x is equals to x 2x squared minus x plus 1. That is the equation. So if I'm to respond to that equation, now we know that f at 1 means that wherever we see x, we replace it by 1. So this is 2x squared minus x plus 1. So now we have 2. Now in place of x, we replace it by 1 squared, then minus, then we have 1, then plus 1. Just substitute it in. Therefore, 1 squared is 2, 1 squared is 1, then 1 times 2 is 2, then minus 1 plus 1. So the answer here is what? The answer here is equals to? The answer here is equals to 2. Now you can now see that f at 1, it says now I need to find the value of y where x is equals to what? Where x is equals to 1. Right. B, I'm going to leave B for you. Where we have f at minus 1, it means now you need to determine what will be the value of y if x is equals to a negative 1. Right, I will go straight to what? I will go straight to C, whereby I have f at 2x. What must happen there? You know very well that you just need to substitute in. So it means you are going to have 2 times 2x all squared, then minus into that 2x, then plus 1. Very important. You can see every time when I substitute something, I put it inside the brackets so that I avoid making a mistake of not multiplying out. That is very, very important. So first, Botman says brackets first. So 2x squared is going to be 2 times by 4x squared, right? Then minus 2x plus 1, because this is positive, this is negative. So positive times negative, then it's going to give us negative. So then we've got 8x squared, 2 times 4 is 8, minus 2x plus 1. That is what we have. Please, very, very important. It means when x is 2x, then the y then will be 8x squared minus 2x plus 1. Right. That is C. Remember I said you do B. Ne? I will check the answer for B immediately after we do E. Keep that in mind. Right, then what about D? For D we have f at x is equals to 0. What is the meaning of that? Yes, I can see one of you were saying that in this case we are given the value of y. Now we need to determine the value of x. You are 100% correct. We have now the value of y. They say f at x is equals to 0. So it means here we are given that the y is equals to 0. What we need to do is to determine the value of x when y is equals to 0. So we have f at x here. This f at x, we substitute it by 0. So it means we have 0 is equals to 2x squared minus x plus 1. Can you see? You will now remember from grade 9 and a little bit earlier on algebra, equation and inequality. Now you spoke about the quadratic equation. Here it comes now. You see now the importance of the algebra here. Yeah, you need to make sure that you understand algebra. Now, it's a quadratic equation in the standard form. Then you know from here you need to factorize. Then the factors here will be 2x as well as x will give us that. Now factors of 1 is 1 times 1. Therefore this will be minus and this one will be positive. Please make sure that you know how to factorize because you need to master it now. Therefore in this case you know we can now say 2x plus 1 is equals to 0 or x minus 1 is equals to 0. Therefore you can kick 1 on the other side. Then we've got 2x is equals to minus 1 divided by 2. Therefore x is equals to negative 1 over 2 or x is equals to 1. Then it means when x is 0, we've got when y is 0, we've got two values of x. The first one is x is equals to negative 1 over 2, and then the other one is x is equals to 1. Very important, f at x is equals to 0, f at x is equals to 5. It means the 0 represented the y, the 5 represented the y. Take note of that. Okay. Right, I'm also going to leave that E for you to do it. Guys, please make sure that you do it, your practice. Remember for mathematics, you need to practice. You need to feel how it's done. Because if you're not going to do, you're just going to watch it, then it means there is nothing that you're going to learn. Because you need to commit those mistakes so that we are able to correct your mistakes. Okay, right, then let's go to the next part. Very important, the straight line. You did a straight line in grade 9. Y is equals to x. You did that. Let's talk about the straight line. Okay, the graph of a linear function is also a straight line. We talk to a linear function, we can also call it a straight line. Right, the standard form of a straight line is given by y is equals to x plus c. The standard form of a straight line is given by y is equals to what? Y is equals to mx plus c. Or if I don't want to say this one, the other form that we use sometimes is what? The other form that we use sometimes is y is equals to, we can say, if you don't want to say y is equals to mx plus c, we can say y is equals to ax plus q. Very important, remember the two. y is equals to mx plus c, we know that one. M represented the gradient. I'm going to talk about that. C is a y value on the graph. Exactly the same thing here. A represented the gradient, and the Q here, the y value, or the shifting of the graph. But these are the things that we're going to talk about them right now. Okay, right, where M is a gradient, I spoke about that earlier on, and the C is equals to the y-intercept. Okay, right, now the effects of M and C in y is equals to mx plus c, right? That's one thing that we're going to look at now, right? I don't want to tell you what is happening. Right, let's look at this graph here. I will study the new one. so that at least we see clearly what is happening. Let's sketch the graph. Which one can I sketch? Let me take y is equals to x. It's a linear, right? It's a linear graph. Here we are. You remember very well from grade 9, this is what you draw. If x is 1, you can use a table. If x is 1, y will be 1. If x is 2, y will be 2. If x is 3, y will be 3. If x is 4, y is 4. Can you see? If x is 5, y is 5. That is why we say we have y is equals to, or here x is equals to x, or y is equals to x. Right, now, what is the value? We said m is the gradient. What is the value of m now? M in this case is equals to what? M in this case is equals to 1. Right. Can I plot the second one? Let me plot the second one, where now we have 0,5x. Where we now have 0,5x. Look at the graph. Look at the graph. Now we have it here. Now it is below now. Let me name the first one. The first one, I call it A. Let me call the first one A. Right. Here we have A, that is the first, which is y is equals to, I want to take it, okay, right, which is, okay, let me take it here. The first one, y is equals to x. Now the second one, let me name it B. Here we are, that is B. Then from there, the B, yeah, no problem with this one. You see now, the value of A here, the y, the gradient is 1. The second one, B, the gradient is 0,5. Thank you. Now, when the values are getting slow, what is happening to the graph? Now, you can see now, it's like the graph is moving far apart from the y-axis. It's moving away from the y-axis. Let me take the last one, which is less than 0,5. Let me take 0,1x. I will take 0,01x. Yeah, let me take 0,01x, or 0,1 is fine. Take 0,1 is fine. There we are. You see what is happening? Yes. Now the last two, where now I have 5x, where I have 5x. Okay, there we are. And then can I take where I have 12x? Where I have 12x. Where I have 12x, then here we are. Can you see that? The 12x, I can't even see. Okay, that is A, B, C. Then we've got 5 here. So where is that one? No, I don't see it. Oh, here it is. Here it is, the 12x. 12x. Undo that. Undo. Okay. Right, that is 5. Let me take, no, 12 is big. Let me take maybe 8x. Right, there is 8x. Now we can see it. Now, can you see, the more the gradient becomes bigger, and the graph now is moving closer to the what? The graph is moving closer now to the y-axis. But now, let us understand what is happening here. Now, I think now you have a clear understanding of the effects of M on the graph. Now, M, like I said, it represented the gradient of a straight line. Now, we now spoke about where M is positive. Now, it means M greater than 0, it means the gradient is positive. We are going to look at where M is less than 0 now. Okay. Right, we said C represented the y-intercept of the straight line, right? And then and also indicated the vertical translation of the graph. If c is greater than 0, then the graph has a positive y-intercept and shift upwards by c units. And then if c is less than 0, the graph has a negative y-intercept and the graph will shift downwards by c. Now let's see what we are talking about. Now, right, I will take this one. Okay, let me hide all of this. Let me hide. Okay, just delete. Thank you very much. And then I delete. Right, let me start first with the one that we know. The Mara graph here, I will put it that way, is y is equals to x. That one, maybe I must ask one question. What is the value of y here? Y is 0. You are very correct. Y is 0. But now, when I have now y is equals to x plus 1, what's going to happen? Let's see. There we are. Right, you said y is 0 here. But what is the value of y here? It's 1. What is the point here? Remember I said the coordinate form, you start with the independent x and dependent y. So x is 0 here, and then y is equals to 1. Tell me what happened to the graph to move from the graph A to B. Then yes, I can see one of you guys you are seeing that the graph moved 1 unit up. 100% correct. And what is this one? That will be the C. If we were talking about the graph that we just sketched now, is y is equals to x plus 1, which is the same as y is equals to mx plus c, or y is equals to ax plus q. Now the c, well stated here, we said now the c here represented the y-intercept of the straight line. You have seen now on the graph that the graph will touch the y-axis at positive 1. And also, it's a shifting. If c is positive, c is a positive 1, then the graph will move 1 unit up. The graph shifted 1 unit up. Please take note of that and don't forget it. Very, very important. Now, in case where I have now, maybe I can do the last one because of time, where I have now x minus 5. What's going to happen? Let's see, can one tell me what's going to happen? Yes, you are 100% correct. Then now, first we need to identify, okay, we said here, the point here is 0, x is 0, y is 0. What is the point here? What is the y-intercept? Then the graph will touch the y-intercept at what? The y-axis at 5. Yes, you are right, at 5. Now, what happened to the graph from y is equals to x? So it means the graph shifted 5 units downwards. What happened? We have y is equals to x minus 5. Look at the last part, minus. Minus says we are going to move 5 units downwards. Plus says I'm going to move 1 unit or shift 1 unit upwards. This value represents two things. It's a y-intercept, number 1, and number 2, it's indicating the shifting of the mother graph, y is equals to x. How this graph shifted, very, very important, because in this case, we are talking to the gradient of what? The gradient of 1. Okay, right, now let's carry on now. We have now C, we understand now when C is greater than 0 and when C is less than 0. Now, what is happening under the functions is there are 3 things that we need to understand and make sure that we master them. I'm just telling you now so that when we carry on with the functions, then you can just tick, I can do number 1, I can do number 2, I can do number 3. The first one is to sketch the graph. You need to know how to sketch all these functions that I mentioned earlier on. And then number 2 then will be, we must be able to determine the equations of all those functions. And the last one then will be, you must be able to do what? You must be able to interpret. Therefore, this is my objective for this lesson. By the end of the functions, if all of you can be able to do the 3, then I would say now we have achieved our objective. Very important for the functions in grade 10, grade 11, as well as grade 12. Now, What we're going to do now, we're going to sketch a straight line graph using the table method. Now we are starting it from grade 9. Now this is what you did. The question says sketch the graph of y is equals to 2x plus 4 by using the table method. Okay, right, now we've got that independent. I selected 2 values on the left hand side of 0 and 2 values on the right hand side of 0. You know, if these are the independent, now dependent 1 to get 0, you just substitute minus 2 into the equation, then you get the y. You do the same, minus 2 times 2 is a minus 4 plus 0. Minus 4 plus 4 is a 0. Then 2 times minus 1 is a minus 2. Minus 2 plus 4 is a 2. Then 2 times 0 is a 0 plus 4 is a 4. And then 2 times 1 is a 2. 2 plus 4 is a 6. 2 times 2 is a 4. 4 plus 4 is a 8. Can you see now? When x is minus 2, these are the y values. Okay. Remember, like I said earlier on, the x are independent because just selected the 2 left, 2 right, and the y values, we can get them by substituting the x value into the equations. Here we are. Now we need now to plot. Remember, I said earlier on, when you sketch the graph, you must be able to plot the points. That is very, very important. Right, here we are. These are the point. The point that we are having here, we have the first one is a minus 2, y is 0. Here we are. Minus 2, y is 0. Right? The other one, we've got minus 2, 0. And then the next one, we have minus 1. If x is minus 1, y is 2. Still remember that on the table. If x is 0, y is 4. Right? If x is 1, y is 6. If x is 2, y is 8. Therefore, these are the points, the coordinates that we are having. Very important, you must be able to draw the coordinates. Right, but what is important here is, look at the x-intercept. When you talk to the x-intercept, is where the graph touches or passes the x-axis. X-intercept is where the graph pass or touch the x-axis. Now, the graph now cut the x-axis at minus 2 and 0. Very important. When x is minus 2, y is 0. That's where the graph cut the x-axis. And also the graph cut the y-axis at 4. What is this point here? X is 0, y is 4. Right. Thank you. Right. Let's now move on. We used the table to sketch the graph. Now the second one that we need now to practice and make sure that we understand is to sketch a straight line graph using the dual intercept method. This is very important, grade 10s. Please make sure that, yes, you know the 2 at the moment because you're going to need the 2 going forward. But you also need to practice this one. Right. They say sketch the graph of y is equals to minus 3x minus 3 by using the dual intercept method. Right. What do we do here? You have learned previous example that when the graph cut the x-axis, at that point y is equals to 0. And when the graph cut the y-axis, and then at that point x is 0. Now we're going to use the very same thing where for x-intercept, because that's where the graph cut the x-axis, then y at that point is equals to 0. So we substitute y by 0. That is why we have 0 is equals to minus 3x minus 3. And now, you see now I've got the linear equation. Very important. And how do I solve the linear equations? I kick number on the other side, or unknown one side, numbers on the other side, the constant on the other side. So it's a minus 3. I take it on the other side. It becomes now positive 3x is equals to minus 3. Then I divide by 3, x is equals to minus 1. It means the graph will touch the x-axis at minus 1 and 0. Very, very important. Right, what about the y-intercept? Y-intercept, the graph cut the y-intercept, y-x is 0. Very, very important. Now, what is happening here? We must let x to be 0. Then we substitute it into the equation. Y is equals to minus 3 times 0 minus 3. Therefore, we have y is equals to minus 3. Our understanding here is that when x is 0, then the y then is minus 3. That is where the graph will pass. Let's see how the sketch looks like. Then we have 2 minus 3. Here it's a minus 3. That is a what? That is a y-intercept. Remember how we have obtained that? We did substitute here by 0. So minus 3 times 0 is a minus 3. Then we have it. Then, but what is the x? The graph will cut the x-axis at -1. How did we get that -1? Then we said, okay, y is 0. Then we moved 3 on -3x on the other side. It becomes positive. Then we solved for x. That is why we have obtained that -1. Grade 10, please, very, very important. Make sure that you know how to sketch the graph using the table. And also you know how to sketch the graph using what? Using the dual intercept method. For x-intercept, y must be 0. And then for y-intercept, x must be 0. Okay, right. Now we have this one, another one, sketching the straight line graphs using the gradient intercept method. That is another one that you learned also in grade 9. Example here, they say sketch the graph of g at x is equals to -1/2, 1/2 x by using the gradient intercept method. How we do it? Let's look at it. Right. This is the graph that we are having. Right. We say the negative sign indicates that the line slope to the left and the y-intercept is 0. Yes, there is no c here. If there's no c, it means the graph will pass at origin. But if it's negative, then it says the gradient, the graph is decreasing. Right. The numerator, this one, numerator tells us that tells us to shift 1 unit up. This one here, we shift 1 unit up. Right? From there, right, numerator tells us that we shift 1 unit up from the y-intercept, and the denominator tells us that we shift 2 units to the left. Therefore, you go up, and then from there, you go 2 units to the left. Very, very important. Because of that negative. If it was positive, then we'd move 2 units to the right. Please, you can even use the table method. You will see that you'll exactly get the very same graph. Practice this one. Yes, the more you know the different way of sketching the graph, the better for you. Okay, right. The other ones that we really need to take note of is the horizontal line as well as the vertical lines. Guys, horizontal line, what type of the line are we talking about? Yes, I can hear some of you are saying something, but I'll come back to that. And then what about the vertical line as well? Okay, right. Now, horizontal line, yes, you are right to say, is that line that touches only the y-axis. You are 100% correct. And the vertical line you are saying is a line that touches only the x-axis. Yes, let's look at it. Now, here they're saying, sketch the graph of y is equals to 2. Right, now we are going to use the table because of you don't know what's going to happen here. In this relation, the x value can vary, but the y value must always remain the same. We are going to have a different x values, -1, 0, 1, 2. But look at what is happening at y. We have the same y values. When x is -1, y is 2, 0, 2, 1, 2, 2, 2. So line which cuts the y-axis, and this line is parallel to the x-axis. Is parallel to the x-axis, have the equation y equals to the constant. It means that line that is parallel to the x-axis. Maybe I need to indicate when I talk to the parallel. When I talk to the parallel, it's something like, remember, this is the y, this is the x here. Right? The line that is parallel to the x-axis is like, you remember, must have parallel from grade 8 and grade 9. So this is the line that I'm talking about. This line cuts only the y-axis. So it means the equation of this is y is equals to the c, or the constant, or the q. Now the same apply. I can also have it down here. It is, but there is no way that this line will touch the x-axis. Then this will be y is equals to minus c, or y is equals to minus the constant. Please keep that in mind. Right, now, what's going to happen here? Let's look at the sketch of that. Here is a sketch. Can you see now, since y is equals to 2, therefore the line now cuts the y-axis at 2. That is why I said this line will be parallel to the x-axis. Very, very important, because when x is -1, y is 2. When x is 2, then y is always 2. Right. Right, let's sketch the graph of x is equals to 2. Let's sketch the graph of x is equals to 2, and let's see what's going to happen. In this relation, the y value can be different, but the x values must always remain the same. So why are we saying this one? Look at the x, 2, 2, 2, 2, but would have the different y values. This line which cuts the x-axis and parallel to the y-axis have the equation x is equals to the constant, right? The one that we did earlier on, it was just y is equals to 2. But look at this one. It is a vertical line. Ne? It only cuts the x-axis. It only cuts the x-axis, not both, only one. So that is why you see when y is minus 1, x always 2. X always 2. X2, y minus 3. Can you see that? So this one we say is parallel to the what? Is parallel to the y-axis. Very, very important. Please take note of that. We also have the horizontal, which is parallel to the x-axis. We have a vertical, which is parallel to the y-axis. Okay. Right. Now, let's look at this exercise. Please make sure that you do the exercise. I'm just going to do one. They say draw the neat sketch graph of the following linear functions on a separate set of axes. I will do A, then please at your own time, please make sure that you practice as many as possible. Yes, I'm not going to use the 3 method. No. Yes, remember you can use the table method. That is number 1. You can use the dual intercept or you can use the gradient. So that is your choice. That is your choice. Let me start first. The first one, we have f at x is equals to 3x. 3x minus 6. That is that. I'm going to use the dual intercept method just to make sure that we understand. Now, it means for me, the first thing that I'm going to do is to determine x-intercept. I must determine the x-intercept. Right. For x-intercept, I know that y must be 0. For x-intercept, y must be 0. So it means this is the y, like we indicated earlier on when we were talking about the notation. So we have now 0 is equals to 3x minus 6. Right, what do I do now? I can now take 6. Remember now, earlier on we say we are adding to move 6. Now we can now take 6 on the other side. Very important is a minus 6, then it's going to be positive 6 is equals to 3x. And thereafter, then I divide by 3. Therefore, x is equals to what? X is equals to 2. Right, if I were to write this one in the coordinate form, then x is 2, then y will be what? Y is 0. Remember, x-intercept, at that point, y is equals to 0. Right now, when you look for the y-intercept, then what are we having? Then here, x must be 0. X must be 0. Therefore, we have y is equals to 3 times what? 3 times 0 minus 6. Then what's going to happen? We have minus 6. Can you see? Like we said, the value of C, here is our C. It represented the y-intercept. Look at the y-intercept. We still have what? Minus 6. So if I were to write it in the coordinate form, x is 0. We start first with an independent, and thereafter it's a dependent. That's why we have 0 minus 6. Very important. And therefore, the question said we must sketch it. Now, when you sketch the graph, please use the ruler with the correct interval. Very, very important. Use a ruler, correct interval, so that we're able to indicate the coordinates, especially when we are using the table as well as the dual intercept. Very, very important. Right, let me start with the first one. The first point that I'm having, x is 2, y is 0. Where is that point? Yes, I can hear one of you says the point is on the x-axis. You are right. Here is 1, 2. The point is here at 2. 1, 2, 3, 4, 5. This side I've got minus 1, minus 2, minus 3, minus 4. And I have 1, 2, 3, 4, 5, 6. Then I've got minus 1, minus 2, minus 3, minus 4, minus 5. So I have a point here, right? Okay, right. Number 2. Then the second one is a minus 6. Where do I have minus 6? 1, 2, 3, 4, 5, 6. Here's a minus 6 here. So it's a minus 6. So the point is on the y-axis, where x is equals to 0. Then from there, you take a ruler, you join the 2. Then that will be the straight line that you're going to get. Please, very important. This is an example that I did just to show you how it's done. Then from there, please make sure that you do B, you do C, you do D. Practice makes perfect. Very, very important. Okay. Right. The other one says, with each of the following equations below, write the equation in the standard form and then determine the gradient and determine the y-intercept. Very easy to do. I will start first doing the first one. Then you will do the rest, just to show you how it's done. I can see some of you guys are saying, can I do it? Say, can I do it first? No, you're going to have time to do that. Nay. So let's look at the first one. Says A, then we've got 2y minus 4x is equals to 0. What is the question? The question says, write the equation in the standard form. What is the standard form? Y is equals to mx plus c, right? Y is equals to mx plus c, or y is equals to ax plus q. Then the second question is determine the gradient. It means now you must write the gradient of that equation, and thereafter then we write the y-intercept, right? Let's see what are we getting. The first one is to write the equation in the standard form. The standard form, y is equals to mx plus c. That is the standard form. Or y is equals to ax plus q. Right, now, let's do that. What do we do? X must move on the other side. Then it means we have 2y equals to 4x. It's a minus. When I move it on the other side, it's going to be a positive. Thereafter, I can divide by 2. Therefore, y is equals to 4 divided by 2 is 2. Therefore, y is equals to 2x. Here we are. Now, that is the first question. The second one said, what is the gradient? M here is equals to 2. The gradient is equals to 2. That is the second question. The third question was to determine the value of C, the y-intercept. What is the value of C here? Grade 10, you can now see that the value of C here is equals to what? Is equals to 0. Therefore, the y-intercept is what? The y-intercept is 0. In that case, now we can say now the graph will pass through the origin. The graph will pass through the origin. Therefore, it is the same as the one that we did earlier on, y is equals to minus x or positive x, whereby now the c is equals to 0. Right, please. Then you can do BC as well as D. Very important, make sure that you practice that grade 10s. And the other one now, given the following equation, f at x is equals minus 2x plus 1, sketch the graph. You can use the table, or you can use the dual intercept method. And then B, after that, you draw the graph of G if f at x has been translated 2 units up. You know very well what's going to happen. Maybe before I can skip A, and then maybe to talk about the equation of B. What do you think will be the equation of G, right? What do you think will be the equation of G after F been translated 2 units up? Yes, I can see some of you say now the graph will also move 2 units. At the moment, the graph moved 1 unit up. And thereafter, now if you translate it 2 units up, then it means the graph will then be at what value? Yes, I can see now you are saying at 3. Yes, you are right. It will be at 3. Because where we are, maybe I can show you on the graph. Maybe I can show you on the graph very quick so that at least we are sure of what we are talking about. Right, let me quickly share that with you. Okay, let me quickly share that with you. At the moment, what we are having, we have y is equals to, let me check the question quickly. We have y is equals to minus 2x plus 1. Minus 2x plus 1. Minus 2x plus 1. Here we are. Then when we sketch it, the graph looks like this one. It's a decreasing one, touches the y-intercept at 1 and x at half. But now, we say now we move the graph 2 units up. It is here. If you move 2 units up, then it will be 1, 2. It's supposed to be touching the y-axis at what? At 3. Let's sketch and see if that will be correct. Now we plotted the graph. We have now minus 2x. Minus 2x plus what? Plus 3. What do we get? Here we are. So now, can you see now? The graph now, not plus 2. Let me edit that. Let me edit the function. Plus 3. Yes, plus 3. Here we are. Can you see now the graph now touches the y-axis at 3. The graph shifted 2 units up. The graph shifted 2 units up. Please make sure that at the end of the day, when you sketch that graph of G, you must be getting something like what I am having. Okay, right, let me move grade 10s. Remember I said we've got 3 questions. Now we are at the second one, determining the equation of a straight line. We are given now the y-intercept is 3. Here is a question on this side. Let me show you the sketch. On the sketch, we've got the y-intercept at 3. The graph cuts the y at 3. And also we've got a point on that graph, 8 minus 1. You'll see when we get to analytical geometry, then we'll be talking more on the equation of a straight line, where we determine the equation. And at least now we have an idea now of what is happening on the linear function or a straight line. Right now we have the y-intercept, which is C3. Then we just substitute y is equals to mx plus 3. There we are. And then after that, you substitute the point 8 and 1, the x as well as the y into the equation. Your y is a minus 1, then your x is 8 plus 3. Then from there, you times the 2, 8 times m is 8m plus 3. Then from there, you move 3 on the other side, then it's going to be what? You move 8 on that side is a minus 8. You move 1 on the other side is going to be positive. Therefore, 3 plus 1 is a 4. Then you divide by minus 8 on both sides. Then you get 4 divided by 8. It's a 1 over 2, which is negative. Therefore, the gradient there is 1 over 2. Therefore, it says the equation is y is equals to minus half x plus 3. Very, very important. Right now, the other way then will be, remember, we are talking to the equation of a straight line, which is given by y is equals to mx plus c. Now, the question then will be, do I still remember how to determine the gradient? Do I still remember? Yes, the gradient from analytical geometry is given by, okay, m is equals to changing in y2 minus y1 over x2 minus x1. So we can first determine the gradient. How do I determine the gradient? I've got a point 0, 3, and then I've got another point 8 as well as what? Minus 1. Right? These are the coordinates. Né? These are the coordinates. Let us verify that. Yes, these are the coordinates. Then from there, you can just substitute in. Then I say this is x1, y1. This is x2, y2. So first you start with y minus 1 minus 3 divided by then 8 minus 0. Then what do we get? Minus 4 divided by 8, which is the same as what? Negative 1/2. There we are. Can you see? That is another way. First determine the gradient. After that, then we substitute it in. Then we'll be having y is equals to minus half x plus c. How do you get the value of c? You can take one of the points and substitute it in, or you can now remember that the c represented by the y-intercept. Then we're going to have negative half x minus what? Positive plus 3. Then this then will be the equation. Okay. Right, please keep it in mind. We also need to know how to determine the equation. Right. Now, this is the exercise that you must do. Please, grade 10s, just go through it. Right, I'm just going to give you just 2 minutes. I'm just going to give you 2 minutes to do the first one. The very first one, you determine the equation, and then after that, I'm going to do it with you. Now, I'm going to give the solution to that to check if we are correct. Then if not, then you'll do the corrections of that so that you are able to do the remaining one. Right, I think you are done. You must be done by now. Any method is fine, but let me go straight to the one that we started with. Okay, we have y is equals to mx plus c. Because of that point, x is minus 4, y is minus 1. Yes, these are the coordinates of the point on the straight line. Therefore, we substitute in that point. Substitute in the point minus 4 minus 1. Then this is y, this is x. So for y, the minus 1 is equals to m into minus 4 plus 3. Then what do? Then I multiply minus 1 is equals to minus 4m, then plus 3. Thereafter, move minus 4 on the other side, it becomes positive. Then 4m is equals to 3. It's a minus 1, then it's going to be positive 1. Therefore, we have a 4 equals to 4m. Then I divide by 4, m is equals to 1. Can you see? Now we have the gradient is 1. Therefore, now the equation then would be y is equals to m, which is 1, 1x. Then we have the c there. It's a plus 3. Very important. Therefore, you don't need to write that 1x, because we know that if it's like this one, how many x do we have here? 1. So you can just leave it like that. It's a x plus what? X plus 3. It means now the gradient there is equals to a positive 1. Are we fine? Good. Thank you. Right, please do the others. I did A, then you can now do B, you can now do C as well as D. Right, that was the linear. Guys, you can also do number 2. It says determine the equation of the line passing through that point. I would leave it like that so that we're able to copy the questions. Please do them all. And then B, determine the equation of the line with the gradient of minus 2 and pass through the point. On this one, the gradient is given. You don't have to calculate it. You only have to calculate the value of C. Then C says determine the equation of the line which cuts the x-axis at 5 and then the y-axis at minus 2. And then D, determine the equation of the line which cuts the x-axis at minus 3 and the y-axis at 9. Please make sure that you go through the exercise 2. Right, parallel lines. I indicated earlier on that parallel lines have the same gradient. Maybe the question is, are these two lines parallel? How would I see if the two lines are parallel? I must look for the gradient. They must have the same gradient. Very important. They must have the same gradient. Now, at the moment, we've got 2. Gradient is 2. Do I know what is the gradient of this line? No, I don't know. The first thing that I need to do is to make sure that I write the equation in the standard form. Okay. Then, the first one, the gradient is 2. Then this one, we've got y minus 2x minus 6 is equals to 0. Then we rewrite it, so we have y is equals to 2x plus 6. Therefore, the gradient is 2. Then, since the gradient are the same, then we can conclude that, yes, the two lines are parallel to each other. The reason for that, they have the same gradient. Okay, what about this one? We've got 2y is equals to 2x plus 4, and we have minus 2x plus y minus 6 is equals to 0. Right, let's see. The gradient of the first line is equals to 1 divided by 2, so that we have y as a subject of the formula. And then the second line, there it is. We move everything on one side. Then after that, we find that the gradient is equals to 2. No, the two lines are not parallel. Why? Because gradients are not the same. The other gradient is 1. The other gradient is 2. Please take note of that. Take note of that. Thank you. Perpendicular lines. Remember now, for perpendicular lines, m1 multiplied by m2 is equals to -1. When I talk to m1, I'm saying the gradient of the first line multiplied by the gradient of the second line, they must give me -1. If the product is -1, then I would say they are perpendicular. Right, now they are saying, are this line perpendicular? We have y is equals to 3x minus 2 and y is equals to minus 1 over 3x plus 1. So the gradient here is a 3 of m1. The gradient here is a minus 1 over 3 of m2. So when I multiply the 2, the answer is -1. 3 times -1 over 3, then it gives me -1. Yes, they are perpendicular. Right, number 2, exactly the same thing. Here you are. Then y is equals to minus 2x plus 4. The gradient is minus 2. Then the other one, 2x minus 6 is equals to 0. Then I divide by 2. Then I get 1 over 2x plus 3. So the gradient in this case is 1 over 2. So when I take 2 times 1 over 2, the answer is -1. Then I can clearly say now the two lines are perpendicular because the product of the two gradients is equals to -1. Right. I want to finish now the straight line so that at least when we meet, then we go straight to the quadratic function. Right. The two lines can intersect. The two lines can intersect. Now the question then will be, how do we determine that point of the intersection? Right. Very important to know when you talk of the point of intersection, that is where the two graphs cut each other And at that point, those graphs have the same x value and they also have the same y value. Very important. And how can we determine that point of the intersection? We can read it from the graph. It means the graph, the scale very clearly indicated, then we can read it there from the graph. Or if we can't read it from the graph, then we can solve it algebraically. You know, you did simultaneous equations, we can do it that way. This is an example. We've got solve 3x minus y is equals to 4 and 2x minus y is equals to 5. Okay, graphically now you can just read it here. If I see, okay, but this one is a minus 1, x minus 1, and then y also on that side. Yes, that is how you read. You read it on the sketch. What is x here? What is y on this side? That will be the point of intersection. Right, but when you solve it algebraically, then what's going to happen? You are going to solve for x and y, simultaneous equations. Remember, when you are doing simultaneous equations, you did elimination method, and then the other one was substitution method, where you have equation 1 and equation 2. That is the case. Then you've got 3x minus y is equals to 4. Then minus y is equals to, you make y the subject of the formula here. Then we have that equation, then equation 2. Then from there, you substitute equation 3 into equation 2. Then you get x is equals to minus 1. Then after that, you can now have the corresponding y value by substituting x into one of the equations. In fact, yeah, one of the equation or equation 2. Therefore, you have y is equals to minus 7. Therefore, the coordinates of the point of the intersection, x is minus 1, y is minus 7. That is where the two graphs intersect. Please create 10. Make sure that you master this part. Very, very important. Right, I'm just going to leave this one here for the moment so that you can copy the question, draw the neat sketch graph of the following lines on the same set of axes. Here you are. And then from that, and then you'll be able to read the point of the intersection of the graph. And then on this one, then solve x plus y is equals to 3 and x minus y is equals to minus 1. Using the method of simultaneous equation, and then from there we can determine the coordinates of the point of intersection of the following pairs of lines. Then you can either determine it graphically or you can determine it algebraically. Then, like I indicated earlier on, practice. Then after that, that will be perfect. Yes, I'm going to stop on this one. Then we are remaining with the quadratic, which is parabola as well as exponential and hyperbolic. Then that one, then same time next week, we'll talk about it. Just to finish this topic is very big, and that is why I said at the beginning, make sure that you understand it. Please don't remember, for any question, you feel free to ask the questions. If you're not sure, ask your teacher, then you can forward the questions on the center here, then you can talk about them next week. So grade 10, please, I know that the system of rotation really has a negative impact on you. But any opportunity that given, you've got it, you can watch the IBP, go through it, and do as many exercises as possible so that at least you understand what is happening. You are going to need these topics come 2020, come 2022. From my side, thank you very much. We'll meet again next week with the same topic. Thank you.